Hi everyone, my name is Haria Faisal, and for my CNIT 176 Raspberry Pi project, I built a full LAMP web server and a RAID 1 storage array using a Raspberry Pi 4B. The main idea behind this project was to create a real-world IT environment by building a reliable web server with redundant storage. This replicates what businesses expect from IT professionals with things like uptime, data protection, and the ability to deploy and manage servers. I chose this project because I wanted hands-on experience with Linux, server setup, and RAID, especially since I hadn't worked with these components before. Now I'm going to connect what I built to the system's architecture concepts with CNIT 176. The Raspberry Pi 4B uses an ARM-based processor, which is a specific instruction set architecture. Everything I did, like installing packages, creating RAID arrays, starting Apache, ultimately became ARM machine instructions executing on the Pi CPU. In lecture, we also talked about how programs require memory to store instructions, data, stack space, and buffers. My project uses the Pi's memory all the time. Every part of the LAMP server needed RAM to run. Apache needed the memory for the requests it was handling. PHP used memory whenever it ran a script, and even the RAID system used memory to temporarily hold data while it was being copied to both USB drives that were used for the project. My RAID array used two 32 GB USB flash drives plugged into the Pi's USB ports. The Pi USB controller is what actually handles sending data to and from these devices. Anytime I saved something to the RAID array, the Pi sent chunks of data directly to the drives. The Raspberry Pi's operating system played a huge role in my project as well, and this connects directly to the architecture that we learned in class. The OS is basically the manager of the Pi. It decides how the CPU, memory, storage, and devices get used. In my project, I saw this firsthand. The OS controlled how Apache, PHP, and MariaDB ran at the same time, and it decided how much CPU and memory each one got. It also handled things like mounting the RAID array, checking file permissions, and keeping track of every process running on the Pi. Another important part of the Pi's architecture that my project used is its file system structure. In Linux, every storage device gets mounted somewhere inside the file system, and the Pi treats it as a part of the same system no matter where it actually comes from. For my project, I created a new mount point, and once I mounted the RAID array there, the operating system treated it just like any other folder. For my project, I followed two main guides: the Raspberry Pi LAMP server with WordPress tutorial and Stays Right's RAID 1 setup guide. I started by buying two 32 GB USB drives, then updated my Raspberry Pi so everything was fresh and ready for installation. I first installed Apache using the package manager and this sudo command. Once it finished installing, I opened Chromium and typed localhost, and the default Apache test page showed up. That confirmed the web server was running correctly. Next, I installed PHP using this sudo command so the Pi could run dynamic pages. I replaced the default index.html with a simple index.php file, but instead of hello world, I got a directory listing. I wasn't sure why PHP wasn't loading the file, so I continued with the rest of the setup. After this, I installed MariaDB and the PHP MySQL extension so WordPress would have a database to use. I then restarted Apache so it could use the PHP MySQL connection. At this point, the full LAMP stack, Linux, Apache, MariaDB, and PHP was installed and working. After setting up the LAMP stack, I moved into var www.html and downloaded the latest WordPress package. I extracted it, moved all the files into the web directory, and changed ownership of everything to the www data user to Apache so Apache could serve the site correctly. Then I logged into MariaDB, created a database called WordPress, and granted the root user full privileges on it. Once the database was ready, I went to localhost in the browser, filled in the database details, ran the installer, and created my admin account. At this point, WordPress was fully installed and running on my Raspberry Pi. These are some screenshots of me configuring WordPress by selecting my language and creating an account. So to install RAID, the first thing I did was run lsblk, which lists all connected storage devices. This allowed me to see every drive attached to the Pi and identify the 2 USB flash drives that I plan to use. Once I confirmed these devices were correct, I used fdisk on the first USB drive. Inside fdisk, I wiped the existing partition table and created a brand new clean partition. Then I repeated the same process for the second USB, so both drives were prepared identically for the RAID setup. After preparing the drives, I installed MDADM, which is a software RAID controller for Linux. Installing this basically prepares the system so it can create and manage RAID arrays. With MDADM installed, I created a RAID 1 array using the 2 new partitions, one from each USB drive. RAID 1 mirrors data, so anything saved to the array gets written to both drives automatically. After creating the RAID 1 array, I formatted the RAID volume as ext4 so it could store files properly. Then I created a mount point and continued with mounting the array, which made it act like a normal folder on the system. To make the RAID permanent, I added an entry using the UUID of the RAID device so the system can always identify the correct volume on boot. I also updated the MDADM configuration so the Pi automatically resembles the array at start point. After that, I checked the RAID status and confirmed both drives were active and syncing. Finally, when I opened MNT RAID 0, I saw the standard file system structure, which confirmed the RAID volume was successfully created and ready to use. This screenshot shows the final procedures that I just spoke about for formatting and mounting the array. So to show that my LAMP web server is fully working, I tested it by completing the full WordPress installation process, which only works if Apache, PHP, and MariaDB are all running correctly together. In this first screenshot, you can see that the WordPress successfully connected to my database and allowed me to run the installation. This confirms that PHP was being processed correctly by Apache and that MariaDB was accepting connections from WordPress. After that, WordPress completed the setup and displayed a success page with my username. This is really important because it means the server was able to read PHP files, write configuration files, and store data in the database with no issues. Here you can see that the WordPress dashboard and settings page. This shows that the admin panel loads, all the pages render correctly, and the backend is working exactly the way it should be on my Raspberry Pi. This screenshot shows the moment my RAID 1 array was created and formatted. At the top, you can see MDADM is successfully building the RAID device dev MD0. Right after that, the file system creation completed with no errors, which means the RAID volume was set up correctly. I then mounted the array and checked the folder. It only contains lost plus found, which is exactly what a new ext4 file system should have. This screenshot shows the final verification steps I used to confirm that my RAID 1 array was working properly. At the top, the RAID status output shows that my RAID device MD0 is active in RAID 1 mode and that both of my USB drives SDA1 and SDB1 are part of the mirror. The progress bar shows the system syncing and the two drives so they contain identical data. Below that, the df-h results confirmed that devmd0 is mounted correctly as a 29 gigabyte storage volume, which means the Pi is using the RAID array like a normal folder. Finally, lsblk-f shows both USB partitions labeled as Linux RAID member and the RAID array formatted as ext4 and mounted. This proves my RAID 1 array is synced and fully functioning on the Raspberry Pi. During the RAID setup, a warning popped up saying that the disk was in use and repartitioning could be a bad idea. I got scared because I thought it might be talking about my micro SD card, which holds the entire OS. But after double checking the device names, I realized that the warning was only referring to the USB drive I was formatting, not the micro SD card. So it was safe to continue. Another big issue happened right when I started running sudo apt update. I kept getting errors like could not open lock file, no split, and invalid respiratory signatures. I thought it was a permissions problem, but the real issue turned out to be the Wi-Fi network. I was connected to ATT Wi-Fi Quest, which is a captive portal network. Though once I switched to my phone's hotspot, the updates worked perfectly. Overall, this project taught me a lot more than just how to install a web server or create a RAID array. I learned how important it is to really understand the Raspberry Pi's architecture, things like how storage devices are labeled and how different components like Apache, PHP, and MariaDB all work together. I also learned that troubleshooting is a huge part of IT. Every error message I ran into forced me to slow down and actually understand what the system was doing instead of just guessing. If I could do something different, it would be keeping my flash drives. After completing the project, I returned my flash drives to get my money back, but realized after that some of my screenshots were blurry. So keeping parts of the project would have been super helpful. Thank you.